A seal-in circuit allows for continued operation of a process that is started by a momentary event. An example is the starting of an electric motor by a momentary push button. This slide shows the wiring diagram for a hardwired magnetic motor starter. A wiring diagram shows the components in their actual physical relationship. At the bottom right is the hardwired ladder control diagram. The contact in yellow labeled M is the seal-in contact. This contact keeps the motor starter coil energized after the start push button is released. Converting the hardwired magnetic motor starter circuit to be used with a PLC, you have two inputs, stop and start, and one output, motor starter coil. The contact in yellow is the seal-in contact, which allows the motor starter coil to remain on after the start push button is released. When the start push button is pushed, the motor starts the conveyor moving. The conveyor continues to move even after the start push button is released until the stop push button is pushed. Note that the contact addressed to the start push button, I:1/0, is only true momentarily. Interlocking refers to preventing a piece of equipment from operating under a certain set of conditions. The hardwired circuit at the right shows interlocking to require the sequential operation of the motors. M2 will be prevented from operating unless M1 is operating. Motor M3 will not be able to operate unless M2 is operating. M1 would have to be started first, then M2, and finally M3. The normally open contact to the right of the stop buttons in the last two rungs accomplishes the interlocking. Converting the hardwired sequential motor starting circuit to a PLC implementation would look like this. In the PLC simulation, we can start the motors in sequence, M1, M2, and then M3. Stopping any motor will stop all motors later in the sequence. No motor will start till the motor before it in the sequence is on. Using push buttons is another means of accomplishing interlocking. In this situation, each push button has both a normally closed contact and a normally open contact. If the solenoid B push button is not pushed, then pushing solenoid A push button will energize solenoid A. If while solenoid A push button is pressed and A is energized, pressing solenoid B push button will de-energize solenoid A but not energize solenoid B until solenoid A push button is released. Solenoid B will operate the same way. It will only be energized if solenoid B push button is pushed and solenoid A push button is not pushed. This is how the push button interlocking would look when implemented in a PLC program. Solenoid A and solenoid B will not be energized at the same time.